Images produced by plane or flat mirrors are called virtual images. If we were to assign a position to the image, it would be behind the mirror. That may not be obvious to you, as you may want to think of the image as on the mirror surface, but look at the image of the white pushpin. It and the graph paper between it and the mirror can be seen in the mirror, and there is depth to the images. Your eyes see the light as if it is coming from points behind the mirror. There is no focused light there, however, which is why the image is called virtual. To illustrate what we mean, we're going to use a little line of sight geometry to locate the image. The blue pushpin is placed in a position to define a line of sight to the image. Understand that we could put it anywhere, as the actual reflected light is associated with rays that go in all directions, as shown in this diagram. So we are just selecting one of these rays to define a line of sight. But now we define that line of sight as it points towards the virtual image by inserting a yellow push pin so that it blocks the blue pin when we look at the angle that we've chosen. So now, as you can see, the yellow and blue push pins define a line that points towards the virtual image. But we need more than one line to determine the image position. If we do the same thing at another angle, the intersection of the two lines will tell us where the light appears to be coming from. It's behind the mirror, as you'll soon see. So we've inserted another blue push pin to block the image when we look along a particular line of sight. Now, looking along that chosen line of sight, we insert a second yellow pin so that the second blue pin is blocked. Now the second pair of yellow and blue pins defines a second line of sight to the virtual image. So now we are going to use the blue and yellow push pins to draw two straight lines. Where they meet is the virtual image location. We've removed the mirror and sketched a line to represent its surface on the paper. They meet at a point roughly 8.4 centimeters behind the mirror. The pin itself is roughly 8.2 centimeters in front of the mirror. The first distance is called the image distance, and the second the object distance. And given a little allowance for measurement error, we're finding that the two distances are equal, which is a general rule for plane mirrors.